In this video we'll learn about a tool called SQLC in Go, and we'll see how we can use that to auto-generate Go code that presents type-safe interfaces to the SQL queries that we write in our applications. We're going to learn how to install SQLC, how to use it to generate that code, and then we'll see how to use the code that's generated in our Go applications to query and make changes to the database. Now before we start, give the video a thumbs up if you're enjoying this content and subscribe to the channel if you've not already done so, and let's dive in. So let's start by looking at the SQLC GitHub page here, and you can see the About section. It generates type-safe code from SQL. Now if we scroll down we can get a little bit more detail on that. So first of all, the C stands for compiler, and what happens here is a three-step process. To start with, you write normal SQL queries in your code base, and then once you've written those queries you run SQLC to generate code with type-safe interfaces to those queries. And finally, in your application code you can call that generated code in order to get data from the database or to make changes to the data that already exists in the database. Now what we're going to do is go to the Overview section here, and let's start by learning how to install SQLC onto our system. Now when we click that link we're taken to this page, and depending on your operating system you can use one of these commands. I'm using Ubuntu on Windows subsystem for Linux, so I'm going to copy this command, and this uses the snap package manager, and I'm going to open an Ubuntu terminal here, and what we're going to do is paste that command in. So when we run this command you can see that I already have SQLC installed, but if you don't have that, the snap package manager is going to install that on Ubuntu for you, and this command may also download the snap package manager itself. If you're on a Mac you can simply use brew in order to install SQLC. And there are ways to install it directly from Go using the go get command and the go install command. And SQLC also comes with its own Docker image. You can pull that and start the service with the docker run command. So just to verify that SQLC is installed, we can run the SQLC command on this terminal, and you can see we get back the usage section here along with the available commands. Now the most important of these commands that we're going to see very soon is the generate command, and that will generate Go source code from the SQL statements that we are about to define. So let's clear the terminal, and what we're going to do in this video is we're going to generate this code, and we're going to use PostgreSQL as our underlying database. So I'm going to use the sudo service command here, and we're going to look at the status of the PostgreSQL service on this Ubuntu distribution. If I run that you can see I have PostgreSQL running. It's active at the moment, and this is the database that we're going to connect to in this video. If you want to follow along you can download PostgreSQL, and that can be running on Windows, Mac or Linux, or you can use a Docker container for your database. So at this point I want to clear the terminal and go back to the documentation for SQLC, and if we go up here we're going to go to the section on getting started with PostgreSQL. Now if we go down to the section on setting up here, what we can do is we can create a new Go module. I'm going to open VS Code where I have a project open here, or a directory open, that contains a main.go file that's very simple. It just outputs hello world to the terminal. Now I'm going to go to the terminal on VS Code here, and we can run that go mod init command, and let's initialize a module that we're just going to call main. Now when we run that you can see at the left hand side it generates the go.mod file. And at the moment there's not much in that, but we are going to add a PostgreSQL driver for Go a little bit later in the video. So what I want to do now, if we go back to the SQLC documentation, is add some of the files that is expected by the program. And notably we have a file called sqlc.yaml, and this can also be a JSON file if you want, but I'm going to stick with the YAML format. And what we're going to do in this file is we're going to add the code that we can see here in the documentation. So let's go back to VS Code, and in this project we can generate that sqlc.yaml file, and we're going to paste this code in here. And this file is the main configuration file for the SQLC program. When you run the SQLC command, this file must be present in the directory. Now you can see in this file we have an engine of PostgreSQL, and that's because we're using Postgres, but if you're using something like MySQL or SQLite you can change that as you need to. We have a field called queries, and that's set to a file called query.sql that we're going to define in a second, and also a schema file called schema.sql. So we're basically telling SQLC which file in our directory contains the schema for our database, and which file contains the SQL queries from which we're going to auto generate some Go code. and we can see some additional information below. Now the SQLC tool is going to generate a package, so let's call the generated package products, and that's because we're working with imaginary products in that database. And let's also call the out directory products, and I'm going to remove this line with the SQL package, we don't need that. And once we've done that, we're going to define these two files here, query.sql and schema.sql. Now I'm going to start with the schema of the database, so let's create a new file on the left hand side called schema.sql. And what this file does is it tells SQLC about the database schema and about what tables we have and what columns are in those tables in the database. And it's very simple, we just paste the schema as SQL statements. So I'm going to paste one from the previous video here. We're going to create the table if it doesn't exist, called product. And that table is going to contain 5 fields. We have the ID, which is the primary key for the table. We also have the name of the product, which is a varchar, the price, which is a numeric field, and we have a Boolean field called available, and finally a field called created, which defaults to the time at which the new record was added to the table. Now we're going to keep it simple in this video. The schema is one table, so it's a very simple database, but of course in a big application you can have as many of these tables as you need with the schemas defined for those tables. Now once we've created the schema.sql file, we're going to create another file. So let's go back to this sqlc.yaml file, and we're going to copy the name of our query file, and that's query.sql. So let's create that file here. And what we're going to do in here is define the SQL queries from which we're going to auto-generate the Go interfaces. Now this query.sql file is structured in a particular way, so let's go back to the documentation, and you can see the sample schema.sql table in the documentation. This is the query.sql file, and this one defines 5 SQL queries. Now above each query there is a comment in SQL. And if you need to do a comment in SQL, you can use the 2 dashes here. And then we have a particular syntax that is going to tell SQLC a bit more about what we need to generate. Now each query is associated with a name, and that name refers to the function that's going to be generated and which will return the results from the query. And when that function is called, it's going to execute this query against the database, and it's going to optionally return any results to the caller. So the example here is a select statement, select all from authors, where the ID is equal to, and then we have this parameter $1, and we're limiting that to a single result. So this is a query that's expected to return one row from the table. And the generated function will be called getAuthor, and this is a notation here that is going to tell SQLC that we only expect a single result from the table. If we expect more than one result, we have another option here, and that's to use the many notation. So this one, rather than get author, this one is called list authors, and that gets all of the authors from the database table and orders them by the name field. So we can easily define these SQL queries, and some of these do not actually return any data. So if we go to the bottom, we can see an update statement and a delete statement here. So let's look at the delete one. This query will delete from the author table where the ID is equal to the parameter. And by the way, these parameters here, they become parameters to the Go function that's generated from this query, and we'll see an example of that very soon. But for this, we don't expect to return any data. This is just going to remove a record from the table, and this notation here will tell SQLC not to expect anything to come back from the database. Now what we're going to do is go back to VS Code, and we're going to go to query.sql, and let's define a couple of queries here. The first one is just going to list out all of the products that are in our table. So if we go back to the schema, we have this table called product. Let's say we want to get back all of these products from the database, and we also want a query that's going to return a single product by the primary key, which is this ID column. So let's go back to query.sql, and we're going to define these queries now. So the first one, let's give it a name of getProduct, and this is going to fetch a single product from the database and return that to the caller. So we're only going to return a single record here, so we can use that notation there to tell SQLC about that. Underneath that, we can define the SQL statement. So we're going to select all from the product table, but we want to limit to a single product, and we want to do that filtering based on the primary key. So we're going to use a where clause, and we're going to look at the ID, and we're going to use a parameter here, $1. And because we only want one record, we can limit to 1 here. So we expect to see that this is going to generate a function in Go that will allow us to get back a product by its ID. We're going to define a second query now, and let's call this one list products, and this is going to get all of the records, so we can specify that it's not going to be one but many returned rows here. We can use that notation for that, and then we define the SQL statement here. We're selecting all from the product table, And let's use an order by here. We're going to order by the name of the product in this query. So let's save this and we're going to try this out now. We have everything we need to generate some Go code. We have the schema for the table and we've told the SQLC about that, and we also have the queries that we want to define against that table. And what we're going to do here is run sqlc generate in this directory. So let's run that, and what you're going to notice on the left hand side is that it's generated a new directory in this project, and that directory is called products. And if we look at sqlc.yaml, that matches what we had defined in this block here. So let's inspect what we have in that products directory. If we look at the database.go file, this contains code generated by SQLC and we don't want to edit this code. And something interesting here is this new function that we're going to call later in the video. This returns to us a pointer to some queries that are defined, and these queries are defined in this file here. It's called query.sql.go. We're going to look at that in a second, but we can also see that there's a models.go file, and that's generated a structure for our product. And all of the fields in the database are represented in that struct. And what's going to happen in the query file is that we're going to return instances of that structure if we're returning a single entity, or if we're returning multiple, we can return a slice of these product structures instead. So let's look through this file now. The first function that we have is called getProduct, and notice that that matches the name that we defined in the query.sql file for this SQL query here. And what happens in that function is that it takes a parameter for the ID of the product we want to fetch, and then it executes a query here and returns a single row from that query. We create a product structure and we scan the results of that query into that using the row.scan function. And then finally we have our product I. We return that as well as returning the error. Now if we scroll down, we have another function here called listProduct, and that doesn't take any parameters other than the context. And this one returns that slice of these product structures as well as an error if that's raised in the processing. Again, we execute the query using this here and we get back a set of rows. We check to make sure there's no error, and then we defer the rows.close function. We then create the slice of these product structures and we iterate over the results that we got back from the database using the rows.next function. And for each row we create a single product structure, and again we're scanning the results of the query into that structure. And finally at the bottom here we're appending our new structure I for the product to an existing slice of these structures, and at the bottom we're returning that to the caller. Now the important thing about these two functions is that we can just call these from our application code in order to get the results of these database queries from the database. So we don't need to worry about defining the functions and the code that's going to actually execute the logic against the database. If you're using SQLC and if you have your queries defined in advance in this query.sql file, you can auto-generate that type-safe code automatically. So let's do that now. We're going to write some Go code that's going to use the auto-generated code that we see here. Now in order to do that, we're going to need to install a Go database driver for the PostgreSQL database. Now if you watched the previous video on databases that we did in Go, we used this package here. It's called PQ, and this is a Go Postgres driver for the database SQL package. Let's scroll down and we can see the installation command, which is using go get. We're going to copy that and go back to the terminal here, and we're going to paste that into the terminal at the bottom, and that's going to install this PQ package. And if we go to the go.mod file that we see here, you can see that that's now been added to this file. Now what we're going to do is we're actually going to generate the database, and we're going to connect to that database using the database SQL package. And once we've done that, we can then test out the queries that have been generated from this code. So let's do that now. I'm going to expand the terminal that we have, and what I'm going to do is connect to our PostgreSQL database, and I have the PSQL tool installed. We're going to connect as the Postgres user, and then once we're connected to the database, we're going to create our own database for this video, and I'm going to call that SQLC test. So let's execute that query, and that will create the database on PostgreSQL. We can then connect to that database using the /c command here. So we specify the name of the database, and that's us now connected to our new database. Once we're here, we can actually create the table that we have here in the schema. So I'm going to copy the SQL query that we have here in the schema, and we're going to paste that into this PSQL tool, and we're going to execute that, and that's going to create the table inside our new database. And just to verify that, what we're going to do is we're going to display the tables, and you can do that with /dt, and you can see we now have a table with the name of product. Now at this stage I want to insert some test data into the table, so I'm going to use an insert into product statement, and we're inserting data for the name of a product, the price and the available field, and we're setting those to these values here. So let's execute this, and that's going to insert that new product into the table. We can verify that with select all from products, and it's actually the product table, not products. When we execute that, we get back that single row that we just added. Now what I'm going to do is clear the terminal, and I'm going to paste 2 more insert statements into this table, and that means that we now should have 3 products in this table, as you can see here. So that's our test data. You can add as many of these as you like. Once we've done that, we're going to go back to the main.go file, and we're actually going to start writing some application code now. So let's start by removing the print line function, and we're going to create a variable here called connection string, and we're going to set that equal to a Postgres connection string. So we use the Postgres protocol, our user is called Postgres, and then we can put in the password for that user. And for me, I have a password of secret on this database for my super user, not recommended in production. And once we have the username and password, we can specify the host, and that's just going to be localhost in my case. And the port number is the standard 5432 port on PostgreSQL. Now the name of the database that we're going to connect to is the one that we just created using PSQL, and that's the SQLC test database. And I'm going to add the SSL mode disable query parameter. So that's our connection string. We are now going to connect to the database. So we're going to create a database, and we can also get back an error from this. But what we're going to call here is the sql.open function in Go. And if you want more information on this, check out the video we did on databases in Go. Now we're going to connect to Postgres, so let's pass that in there. And we're also going to pass in our connection string as the second parameter. Now once we've done that, let's save this, and that's going to auto import the database SQL package. Now we can defer db.close, which is a best practice. And finally, we're going to check if we have an error. So let's check if the error is not equal to nil. And in that case, we're going to use the log.fatal function, and we're going to log out some information about the error. And we're getting a message here that we should check the returned error before we call db.close. So I'm just going to move that down below this if statement. And let's now test out this program to see if it can connect to the database. So at the bottom in the terminal, what I'm going to do, let's expand this, and we're going to quit out of PSQL using /q. And then we're back in the main directory. We can run the go run command, and it's the main.go file. And we can see we have an unknown driver of Postgres, along with a message saying we might have forgotten an import. And that's true, that's exactly what's happened. We installed the PQ driver for Postgres, but we haven't imported it at the top. So let's import that at the top, and we're using the underscore to tell Go that we're importing this only for its side effects. And at the bottom, we're going to try running go run main.go, and this time we don't get any output, and that means we have no issue here. We're not getting that log.fatal call, and we have connected to our Postgres database. So let's now get access to the queries that were generated here for listing out the products and for getting a single product. Let's go to main.go, and just underneath this defer statement, what we're going to do is we're going to create a context object by calling context.background. And when we save that, it's going to auto import the context module at the top. And after we've done that, we can get a reference to our queries. And what we're going to do in order to do that is we're going to import the products module that was auto generated by SQLC, and we can call that new function. And we pass in our database here to get access to these queries. So if you're wondering why we're doing this, let's go back to database.go, and this new function will take a database object as a parameter, and it's going to return to us a set of queries that we can then execute against the database, as we're about to see now. And these queries here, these all take a context as a parameter, and that's why we are instantiating some context here. Let's start by listing out all products. So in order to do that, we need to call one of the functions that we have generated, and that's the list products function that we have here. So let's go back to main.go. We can just use these queries that we have here, and if we look at the auto completion, we have reference to all of the functions that were auto generated by SQLC. So we're going to use the list products function, and we're going to pass our context into that. And if you look at the signature of this, it's going to return two things. It's going to return a slice of products, and this might also produce an error. So we're going to store these in variables. Let's start with the product list and also the error, and we're going to get those back by calling queries.listProducts. And again, we need to check if the error is not equal to nil. So let's copy the if statement here, And finally, if we don't have an error, we're going to call the format.println function, and we're going to print out the product list that we got back from that query. So is this going to work by calling this function that SQLC has generated? Let's test it out by expanding the terminal, and we're going to run the main.go file. Now you can see in the return statement that we have a structure here for our book product, and then we have a second structure for a TV product, and finally another structure for the video game. So this list products function has been auto-generated by SQLC, and when we call that function, we're getting back a slice of these product structures that we can then use in our program. So that's very convenient, and it shows the power of SQLC. All we need to do is generate a query here and store it in this query.sql file, and then SQLC will automatically generate the type-safe Go code for that query. Now if we go back to main.go, we can actually iterate over the results here. So I'm going to go down to the bottom of this, and we have the variable product list. Let's create a for loop now, and we don't need the index, but we're going to get the element when we use range here over our product list. And for each element in the product list, let's use the println function, and we're going to print out the element's name and its price. So let's test this out. At the bottom, we're going to run go run main.go, and this time we get a different output. We can see on each line the name of the product as well as its price. Now what about fetching a product by its ID? We have another query here if we go back to this file, and that's the get product function that's going to return that. And importantly, this takes an ID as a parameter, and the reason for that, if we go back to query.sql, is because we defined a parameter here using this notation. So let's go back to main.go, and we're going to change this line of code here. So rather than getting back a product list, we're going to get back a product, and we're going to call the get product function here, and as well as passing in the context, we're going to pass in an ID. Now I'm going to hard code this to the ID of 1. If we go down below this if statement, we're going to remove the for loop, and I'm just going to use the println function to print out the product that's coming back from the database. So again, let's go back to our terminal, and I'm going to make this bigger and run main.go, and this time we only get back a single structure that represents the product with the ID of 1. Now what if we pass in an ID that doesn't exist here? So instead of 1, we could pass in 111. If we go back to the terminal, we can run this, and this time we get back an error, and that's that we have no results in the result set, and we have an exit status of 1. And we can actually handle this when we don't get the results that we expect from the database. We can check if the error is equal to a particular type of error from Go's SQL package, and that's the error no rows. So if that evaluates to true, we know that we haven't found any rows with our query, and we can handle that gracefully rather than exiting with the status of 1. For now, I'm just going to pass a println function, and we're going to print the message that there was no product with this hard-coded ID. So let's go back to the terminal, and we're going to rerun this, and this time we see that we get the message, and we're also getting the error because I didn't return from this. So this isn't particularly graceful, but we're just going to do it for this example. When we rerun this, we get back the message, and the program did not exit with the status of 1, so it's up to you as the programmer to define what happens if no rows are returned. So let's add some more queries to this application. If we go back to query.sql, at the moment both of these are retrieving data from the database. What happens if you want to actually add a new product into the table? Now this video is getting quite long, so I'm just going to paste these in here. If we want to create a product, we're going to give the resulting function a name of create product, and that's going to return a single entity from the database, and that's the newly created product. And the query for that is another insert into statement. We're inserting into the product table, and we're going to create the product with a name, a price, and the available field set to the values, and we're using these parameters here of 1, 2, and 3. These will become parameters to the create product function when we run sqlc generate, and what's passed into that function will define what's created in the database table. And finally, we're returning all of those to the caller, and that's why we're going to return a single entity, and we're using that 1 notation here. So let's now go back to the terminal, and we're going to run sqlc generate, and I'm going to clear the terminal out before we run that. So let's do that now. Now you don't see any output here, but if we go back to the query file that we have some new structures in here. We have one called create product params, and that contains the name, the price, and the available fields that need to be passed in order to create a new product in the database. And then below here we have a new function called create product, and that accepts that structure with the type of create product params, and it's going to return that single product after it's been created to the caller. So what we're going to do is go back to main.go and we're going to remove the code that we have here. So let's start by removing the check for the error no rows. We don't need that anymore. And what we're going to do here is we're going to change this query that we're running, and instead of the get product, we're going to run the create product query. And again, we need to pass in the context, but we also need to pass in something else here. And if we go back to the query file, it's this structure here that contains the fields for generating the new product. So let's do that now. We're going to reference the product module, and it's the create product params struct that we're going to use here. So we need to pass the fields for our new product. So let's say the product is called coffee machine. So we'll give it a name of coffee machine, and we're going to give it a price here of, let's say, 125.55. And we have an available field too. Now this is an interesting one. If we go back to query.sql.go, this field is of type sql.nullBool. And if we hover over that, we get more information that a nullBool, it represents a Boolean column that might be null. So we're going to need to create this object here in the structure that we're passing into the create product function. So let's do that now. We're going to use sql.nullBool, and that takes two fields here. First one is the actual Boolean value itself that we're going to set to true in this case. And secondly, we're going to pass a field called valid that we're also going to set to true. And if you're wondering why we're passing these, let's again hover over nullBool. This is actually a structure and it contains these two fields, and the valid field is going to be true if the Boolean is not null. And that applies here because we're setting bool to true. So we can also set valid to true, and that's going to be the value for available. Now all of the code that we have below can stay the same. We're still getting back a single product when we call the create product function, and we can print that to our terminal using print line below. So let's go back to this terminal and we're going to run the main.go file, and this time we get back a structure containing our new product. So we have the ID of 4, we have the name of the product, which is a coffee machine, and so on. And what I'm going to do is use PSQL to connect to our database. So we're connecting as Postgres to the database of SQLC test, and then we're going to run a select statement. So select all from the product table, and what we want to see here is our new product in this table, and we can see that at the bottom. It's called coffee machine, and that has been added from our Go code using the auto-generated code from SQLC based on this query that we defined here. Now I want to quickly show two more examples very quickly at the end of this video. We're going to again paste these in. Let's say that we also want to be able to delete a product from our application code. And again, the workflow is the same here. We just go to query.sql and we can paste in the query here along with this metadata above. So the name of the generated function is going to be delete product, and we're using the exec notation because it's not going to return any rows. And the query itself will delete from the product table where the ID is equal to the parameter that's passed into the function. So again, let's go back to the terminal and we're going to run sqlc generate. And when we run that, if we go back to our query file here, if we scroll down, we are going to see that we have a new function here called delete product, and that takes that ID as a parameter and it's going to execute the query in order to delete the product from the table. So let's show how to use that now. If we go back to main.go, I'm going to remove this code here. We don't need that anymore, and we can also remove the product because our new delete function is only going to return an error potentially. So we're going to use the queries here, and this time we're going to call the delete product function. We pass the context into that, and I'm going to hard code another ID. Let's get rid of the product with the ID of 1, and we can remove this line of code at the bottom here, and we can set this to an equals statement. So again, on our terminal, we're going to run the main.go file, and again, let's go back to PSQL and we're going to inspect that table that we had before. So let's select all from the product table, and this time we can see we no longer have a product with the ID of 1. It's been removed from the table, and that's because we've called delete product and passed that ID in. So using these queries that we've defined in query.sql, we can now fetch data from the database, we can insert data into the database, and we can also remove data from database tables as well. Let's finish with a very simple example of aggregation. Let's say we wanted to sum up all of the prices that we have for products in our database. We're going to write one more query in this file, so I'm going to paste that in here, and the resulting function will be called total price, and that's going to return one item from this query, and what we're executing here is a select statement, and we're summing up the price column and casting the result to a float from the product table. So just to demonstrate what this select statement is doing, let's go back to PSQL, and at the bottom I'm going to paste that in here. When we execute that, we get back a single number, and that's the sum of all three of these prices. So we're going to represent that using our Go code, and we're going to call a function called total price to get back that number. So again, let's go back to the terminal, and we're going to quit out of PSQL. Now what we can actually run here, if you're interested in vetting the code that you've added to query.sql, is the sqlc vet command, and that will return no output if everything is fine. But if there's any problems, for example if we've named the table incorrectly, when we run the vet command, it's going to tell us about that. For example here, when it tells us that the relation products does not exist. So anytime you make changes to query.sql, you can run this vet command in order to make sure that everything is as expected. So let's clear the terminal, and we're going to run the generate command one more time, and let's go back to the query.sql.go file, and we can look for that function called total price that was generated, and we can see the logic for that function here, and that's always something you can analyze when you generate your code. Let's now call that function called total price, and that's going to return a floating point number and the error, and we don't need to pass a parameter into that. Let's get the total here and also the error from that query. Again, we check if the error is not equal to nil, and then at the bottom we can print out to the terminal the total. So on the terminal one more time, if we run main.go, we get back the total here of 547.53. So that's all for this video. We have seen how to use SQLC in order to generate automatically code in Go that we can use in our applications, and query databases for data, create new items in the database, and also to perform basic aggregation. And the process for using SQLC in a Go application is very simple. First of all, we define the global configuration for SQLC that tells it where to look for schemas and for queries, and also where to put the generated code in your project. Once you've done that, you can define two files. One contains the schema of the database that you're connecting to, and that will tell SQLC about the columns and the tables in that schema. And also we have a query file, and you can put any number of queries that you want to execute against the database into this file. And this can take select, insert, update and delete statements. And you can also perform aggregation queries in order to get back aggregated data. And if you need to pass parameters in, for example here when we fetch a product by its ID, you can do that very easily with this notation here. So I hope this video has been useful. If you have enjoyed it, give it a thumbs up and subscribe to the channel if you've not already done so. And if you're enjoying this content, consider buying the channel a coffee. There's a link in the description. It would be greatly appreciated. Thanks again, and we'll see you in the next video.